Bridges, section 6.3, adding and subtracting rational expressions. Well, basically, unlike multiplication, when you either add or subtract a rational expression, it's just like a fraction. When you add or subtract a fraction, you have to get a common denominator. So, consider this. If I had x over x squared minus 2x minus 3 over x squared minus 2x minus 3. Notice that the two denominators are the same, therefore I can just subtract. And when I subtract, I'm basically going to take the numerators and make a subtraction problem up there in the numerator of the new fraction. So this would be x minus 3 over x squared minus 2x minus 3. And then at this point, if I were to simplify this, I would have to factor, because as we know so far, factoring is the key to everything with these rational expressions. So anyway, if I have x minus 3, notice that this denominator, we ask ourselves, what multiplies to give me negative 3 but adds to give me negative 2? The x plus 1 and x minus 3. Notice that the x minus 3's will cancel. There'll be a 1 left in its place there, and I'll have 1 over x plus 1. Now, let's say I have 7 over 6x plus 5 over 8x. Now notice that both of those denominators do have an x in common, but I need to find a common denominator between 6 and 8, and that would be 24. So, in order to get a common denominator here, multiply top and bottom by 4 there, multiply top and bottom by 3 here. So that would be 28 over 24x plus 15 over 24x, which would be 43 over 24x. And that doesn't simplify at all. 43 is prime. So that would be your answer right there. Now let's make this a little more complicated. So let's say I have 3 over x minus 3 minus 5 over x plus 2. Now, whenever I ask kids what the common denominator is here, a lot of times I'll get x, or x is a common factor. But if you notice, like if one of these, if I had like an x plus 2 over an x minus 3 and I asked you to cancel something, you couldn't cancel anything because of the plus 2 to the minus 3. Those don't actually have a common factor at all. Okay? And so, as a result, when we get a common denominator, it's like if you're looking for the common denominator between 5 and 7. 5 and 7 only have a common factor of 1. The common denominator between 5 and 7 is 35. That's what they both divide into. And so, in this case, so that would be when they're multiplied together, just the 5 times the 7. So in this case, I'm going to take this guy right here and multiply it by this guy right here, and that's going to be my common denominator. Now notice that, let me rewrite this. So I've got 3 over x minus 3. So that's already got the x minus 3 in it. What it needs is it needs the x plus 2. And so what we do is we go ahead and multiply top and bottom by x plus 2 to get that common denominator. Minus. And actually what I'm going to do is instead of a minus here, to avoid making a sign mistake, I'm going to make that a plus. I'm going to make this negative 5 over x plus 2. I'm only going to distribute the minus to the top part, because if you distribute it to both parts, then you'd end up with something like negative 1 over negative 2. And do you notice that the negatives cancel out? That would be pointless anyway. So I'm only going to change the sign on the numerator. And then, since this already has the x plus 2, I'm going to need x minus 3 on top and bottom here. So what I'm going to do is on the bottom, I'm going to keep this factored. So x minus 3 times x plus 2. And then I'm going to go ahead and distribute in the numerator. So 3 times x is 3x, 3 times 2 is 6, plus. Now on this one, I've still got x minus 3 and x plus 2. But I'm going to distribute the negative 5. So this would be negative 5x. Negative 5 times negative 3 would be plus 15. Notice at this point I can combine these two fractions by adding them together, and since they have the same denominator, I can combine like terms. So 3x minus 5x is negative 2x, and 6 plus 15 is 21 over x minus 3 times x plus 2. Now notice that negative 2x plus 21 doesn't factor at all. Therefore, I cannot cancel out any of the factors. So this right here would be my answer. All right, continuing. 6x over x squared minus 4 plus 3 over 2 minus x. Now, in order to get a common denominator here, what I'm going to do is I'm going to see if these two have a common factor. So I'm going to factor the denominator in the first fraction. So x squared minus 4, that's x minus 2, and x plus 2. Plus. Now I want you to observe something. Notice that I've got an x plus or an x minus 2 right here. But notice that this piece is 2 minus x. And so what we have is that's actually the opposite. What I can do is I can make this into negative 1 times x minus 2, and then I can bring the negative 1 and combine it with the 3 and make that into a negative 3 over x minus 2. So in order to flip the 2 minus x around, so in order to flip that around, I just introduced this negative 1 right here. And then this matches up with that right there. Oh, I can move that. That's cool. So anyway, that matches up with that one right there. And so notice that since I've got a common factor between those two, all this second fraction really is missing is the x plus 2. So I can leave the first fraction alone, and then this one I'll multiply by x plus 2 on top and on bottom. Let me move this. So if I do this, this will be 6x over x minus 2 times x plus 2 plus, then I'll have, when I distribute, negative 3x minus 6 over x plus 2, x minus 2. At this point, we can put these together and combine like terms. So 6x minus 3x is 3x minus 6 over x minus 2 times x plus 2. And observe that the numerator is factorable. You can take a 3 out of that. 3 x minus 2 over x minus 2 x plus 2. Observe that the x minus 2's cancel. And I end up with 3 over x plus 2. X over x squared minus 5x plus 6 minus 1 over x squared minus x minus 2. Again, it's going to be critical that we be able to factor this. So let's factor the first denominator what multiplies to give me 6 but adds to give me -5, that'd be x minus 2 and x minus 3. I'm going to change this to plus. I'm going to make that -1 over, and then this one would be x minus 2, x plus 1. So, we can observe here that both of these have an x minus 2 in them. Okay, so that's going to be part of my common denominator. But this one has an x minus 3, this one has an x plus 1. So if I look at this first fraction right here, it's got the x minus 2, it's got the x minus 3, but it doesn't have this x plus 1 over here. So what I would need to do is I would need to multiply top and bottom by x plus 1. That way we can have the denominators both be the same. Then, if I look at the second fraction, I got the x minus 2, I got the x plus 1. I don't have the x minus 3. So I need x minus 3 here and x minus 3 there. So when I multiply that out and I distribute in the numerator, so I'm going to take this and I'm going to distribute it there and there. Then take this guy and distribute there and there. So let's see, I'll have x times x is x squared plus x over x minus 2, x minus 3, and x plus 1, plus, when I distribute the -1 up there, that'll be negative x plus 3 over x minus 2, x minus 3, and x plus 1. Notice that I just made the order match. The order when you multiply those doesn't really matter, but to indicate that those are the exact same denominator, I changed the order a little bit to make sure that they match. Now, at this point, we're going to combine like terms in the numerator because I do have a common denominator. So this would be x squared doesn't combine with anything, so that'll just be x squared. Now notice that this x here and this minus x here will cancel out. So I'll have x squared plus 3 over x minus 2, x minus 3, and x plus 1. Also observe that x squared plus 3 is not factorable, so therefore I can't reduce anything. This is my answer. And the assignment for this section is on page 395. And on page 395, I need 44 through 60 even. Make sure you label these notes with the section number when you get them checked off. Just a reminder.